Hi there, welcome to Eduretics, where we make your high school life simple. I'm Aniket, and in this video, we're gonna crush some hard difficulty problems from the digital SAT Math section using the DESMOS graphing calculator. And trust me when I say this, you're not gonna need any other DESMOS resource to practice with. Okay, the digital SAT is not gonna be the same anymore. Okay, after you watch this video, after you're aware of the kind of tricks that can be used with DESMOS, it's not going to be the same anymore. So let's get started. Follow along, practice alongside, and if there are any questions, you can ask in the comments. Okay, let's begin. Okay, so let's start. The first question, there are two equations given to us. 5x plus 14y is equal to 45, 10x plus 7y is equal to 27. The solution to the given system of equations is x comma y. What is the value of xy? So they're asking for us to first find the solution of the given system. It'll be in the form of x comma y, the coordinates, and then they want the product of the coordinates. Be careful. They want the value of x times y. So let's check using DESMOS. This is the DESMOS interface that you're going to see on your digital SAT test. Okay, so I'm using the same one to make sure that there's no difference between what we're doing here to what you would be doing on your paper. Okay, so the equations are 5x plus 14y is equal to 45. Let's put the first equation here. 5x plus 14y is equal to 45. That is graphed in red. Second equation, 10x plus 7y is equal to 27. 10x plus 7y is equal to 27. Okay, so as soon as you click on one of the two lines, you will see the point of intersection. This one is the point of intersection, and it's given to be 0.6 comma 3. So 0.6 comma 3, that means our answer is going to be 0.6 comma 3. So 0.6 multiplied by 3, or 1.8. That's the answer to this question. Okay, let's go to the next one. The next question goes, an economist modeled the demand Q for a certain product as a linear function of the selling price P. Okay, so the demand Q depends on the selling price P. The demand was 20,000 units when the selling price was $40 per unit, and the demand was 15,000 units when the selling price was $60 per unit. Based on this model, what is the demand in units when the selling price is $55 per unit? Okay, so in the usual case, while doing this manually using the linear equations concepts, you would first formulate the equation, then you would put in the value of S as $55, and then try to find out the value of Q, the demand. Let's do this using DESMOS. How do we do it? We have 2 points given. So if we check the Q is the y-axis, Q is the y coordinate, P is the x coordinate. Q is given to be 20,000 when P is $40, and Q is given to be 15,000 when P is $60. Okay. So these 2 points are given to us. From these 2 points, can we form the line on DESMOS? That's the question. Okay, so let's check. Now focus really carefully. I'm going to tell you the process on when you're not given the equations. How do you figure out the line? Like how do you input the coordinates and then figure out the line? First of all, you take table. If you take expression, it's like this. You write y is equal to something 7x plus something. Instead of that, you're going to input values of the coordinates, coordinate points. Okay, so x1 is when the selling price was 60. The demand, that was, let's say, let's check the point. At 60, it was 15,000. Okay, so you write as it is, 15,000. At x is equal to 40, when the price was 40, the demand was 20,000. 40, the demand was 20,000. Okay, now we have put in 2 points. As you can see in this one, so I'll just change the axes to more favorable values. Okay, so on the y-axis we need bigger steps. So I'll just do y-axis steps to be This will be 50,000 and this will be negative 50,000, and the step is going to be 5,000. Okay, the step is going to be 5,000. And x, let's do for the x-axis. X-axis I'll take for better visibility, try to keep everything in the visible frame. Okay, so x can go up till, let's say, 80, and on the 0 side we can say it'll go, let's do negative 20. Okay, and the step for x would be 10. Okay, so the 2 points are visible here now. Now, these 2 points, even if they're joined, so how do you join the 2 points? You long press on this icon, the black icon, and click on lines. You can see, and the type of line, dotted, dashed, whichever you want. So I'm taking a solid line. But this does not satisfy our purpose. Why? Because we want to find out what the value of y would be at x is equal to 55. Okay, we don't know that. At x is equal to 55. Can we figure that out? Does Desmos give us the point of intersection between this shown black line and x is equal to 55? I put x is equal to 55. You see, we have attained the point, the intersection, but it's not showing the coordinates of the point. So how do we do that? For that, on Desmos, you need to graph the complete line. This one, the 60, 15,000, 40, 20,000. From that, you need to graph the complete line. Now, this is a trick. This is a weird trick, but I'm going to tell you. So it's called regression. We'll actually do linear regression to find out the equation of the line that is formed using the given points. So let's do that. For regression, you will write y, or y1 is equal to, okay, is equal to b0, b0 plus b1 x1. This is the general equation of a line, okay, on regression. So as you can see, when I write y1 is equal to b0 plus b1 x1. Okay, I've done everything right, but it's still not giving me anything. Why? Because for regression, now be very careful, for regression you don't need to put the equal to sign. You'll rather put this sign. You see this curved sign, which is just on the left hand side of the numeric 1 button, okay, on the top of the keyboard. So now you see this is a line. The complete line is formed now here. From these 2 points, we have done the regression. So basically b0 plus b1 x1 is nothing but y is equal to mx plus c. M and c, the constants, are represented by b0 and b1 in this case. So as soon as you write this expression, like the moment you put in that cliche symbol, okay, after that, so I write b0, it has straight away caught that you're writing a regression. It straight away catches that. So b1 x1, not x but x1, and not y but y1. Now that line has been graphed in green, and x is equal to 55 is graphed in green again here. This is the point of intersection. You can see the answer, 16,250. The direct answer is here. Why I took so much time? I took that much time to explain to you how to do the regression. Now from here on, you won't need to put in more than 30 seconds to solve any such question. Okay, so we're directly getting the answer as 16,250. Let's check in the options. 16,250 is option A itself. So you got the answer. This is it. And otherwise it would have been like a long question for you to solve. Okay, going for the next one. Make sure you understood the regression. You're not going to see that anywhere else. Okay, that's like a hack which we've done to actually graph any kind of function and any kind of equation, any kind of function just by the given points. Okay, let's go for the next one. Okay, the graph of the equation ax plus ky is equal to 6 is a line in the xy plane where a and k are constants. Okay, if the line contains the points negative 2 comma negative 6 and 0 comma negative 3, what is the value of k? Okay, so we're given 2 points and we're asked to find what is the value of k. Let's write this explicitly in the form of y is equal to 6. So ax, y is equal to 6 minus ax over k, or 6 over k minus ax over k. This is the value of y. You're being asked the value of k. Okay, now let's go to Desmos. The given points are negative 2 comma negative 6 and 0 comma negative 3. Let's plot them. So clearing this up, clearing everything from the last question. First of all, go for table. Now put the points negative 2 comma negative 6. And what's the other point? 0 comma negative 3. 0 comma negative 3. You can choose to join the points or you can leave them as it is. So I'm going to join. Okay, and before that I need to correct the axes. Let's make the axes normal. So y till 50 and negative 50 with the step at, let's say 10 or 5. Okay, so these are the points joined here. As you can see, I'm just zooming it in. Okay, now we need to form the equation, and then at the end we'll compare that equation. For the equation, just write y1 regression. So that symbol just on the left side of the numeric 1 key. You can call the symbol a tilde or a wavy line symbol. Okay, so let's I'll call this as a wavy line from here on. So y1 is similar to, this is read as a similar to or is linearly regressed. So y1 is equal to b0, since it's a linear equation, so mx plus c, b0 plus b1 x1. You have the values now. So b0 is negative 3, b1 is 1.5. Let's write that on the other side. b0 is negative 3, b1 is 1.5. So negative 3 times negative 3 plus 1.5x. Y is equal to negative 3 plus 1.5x. Okay, so 6 over k is negative 3. K is a negative 2. You found that directly. K is a negative 2 using Desmos. Okay, and what did we do? We just found the equation of the line using regression. Okay, so in regression, you just write the general equation using coefficients like b0, b1, b2, b3 like that. So for example, for quadratic, you will write b0 plus b1 x1 plus b2 x1 squared. Okay, that would automatically pick up, will be picked up as a quadratic. Okay, let's go to the next one. In the xy plane, line k intersects the y-axis at the point 0 comma negative 6. Okay, so basically it cuts the y-axis, or the y-intercept is negative 6, and passes through the point 2 comma 2. Okay, if the point 20 comma w lies on line k, what is the value of w? Okay, so line k, it has 2 points. We have 2 points given on line k. One is 0 comma negative 6 and one is 2 comma 2. Both these points are given to us. If the point 20 comma w lies on the line k, what is the value of w? So if you were to solve this manually, you'll first figure out the equation of the line using these 2 points and then put 20 comma w into the line equation and find the value of w. How do we do it through Desmos? Same thing. Let's go again. 0 comma negative 6 and 2 comma 2. Delete everything and put in the table 0 negative 6, 2 comma 2. Do linear regression, y1 tilde b0 plus b1 x1. You found the complete equation of the line. Now what do you need to do? They asked us for 20 comma w. Yeah, 20 comma w. Put x is equal to 20, x is equal to 20. This is the intersection point, 20 comma w, 20 comma 74. Simple as that. No need to figure out the equation of the line, no need to figure out anything else. 20 comma 74, w is 74. That's the correct answer. W is 74. Okay, let's go ahead to the next one. Guys, remember these are all hard difficulty questions which we're doing like in 10, 20, 30 seconds on Desmos. The functions f and g are defined as f of x is equal to 1 by 4x minus 9 and g of x is equal to 3/4 x plus 21. If the function h is defined as h of x is equal to f of x plus g of x, what is the x coordinate of the x-intercept of the graph of y is equal to h of x in the xy plane? Okay, so x coordinate of the x-intercept, that simply means the moment you say x-intercept, that means the point at which the graph is cutting the x-axis. So y is equal to 0. The point would be something like x comma 0. Okay, and we need to find that, the value of x. For the graph of y is equal to h of x, and h of x is formed by f of x plus g of x. Let's do that. So x over 4 plus 3x over 4, that's an x. Minus 9 plus 21 is plus 13. Or 12, plus 12. Okay, so x plus 12, y is equal to x plus 12. This is the thing. Put y is equal to 0. As soon as we put y is equal to 0, we get x is equal to negative 12. So 0 comma negative 12, that's the point where this function cuts the x-axis. So not 0 comma negative 12, but negative 12 comma 0, because x coordinate is negative 12 and y is 0. So negative 12 comma 0. So negative 12 is the x-intercept. Okay. Let's go for the next one. A number x is at most 2 less than 3 times the value of y. Okay. So x is at most, that means less than 3y minus 2, because 2 less than 3y, it's saying. If the value of y is negative 4, what is the greatest possible value of x? Okay, so this is an inequalities question. So x less than 3y minus 2, this is the first one. Second is y is equal to negative 4. Okay, so let's look at this one. This can be done without the use of Desmos as well, but I just want to show you how to use Desmos for inequalities. So we can first quickly see what will be the solution manually. So y is given to be negative 4. Put it here. X less than negative 12 minus 2. X less than negative 14. So x is less than negative 14. The maximum value of x can be negative 14. Okay, let's look at Desmos. So x less than 3y minus 2. X less than 3y minus 2. Okay, this one here. And then y is equal to negative 4. So if you look at this, what values do we get? This is the point that has the maximum value of x. If you can see, this is the last point. From all the values of x's would be, or all the solutions would be towards the left of this point. Because towards the right, it's not intersecting. The solution regions are not intersecting. Towards the left, as you can see, the darkened region is intersecting with the red line. That means there y is equal to negative 4. So as you can see, the x coordinate is negative 14. That's the maximum value of x, which we can see directly from Desmos. Okay, let's go to the next one. In the system of equations below, a and c are constants. Okay, so half x plus 1 by 3 y is equal to 1 by 6, ax plus y is equal to c. If the system of equations has an infinite number of solutions, x comma y, what is the value of a? Okay, so an infinite number of solutions. For that, what do? Let's use Desmos. First, we graph this equation, the first one. Half x plus 1 by 3 y is equal to 1 by 6. Okay, so clear this all up. Half x plus 1 by 3 y is equal to 1 by 6. Okay, this is the first one. Second one is ax plus y is equal to c. Ax plus y is equal to c. Okay, now we're going to make use of the slider. I go to all. Okay, the blue line is the line which is given to us, and The green line is the one ax plus y is equal to c, which is not certain. And they're saying that both lines, like the system, should have infinitely many solutions. That means both lines, like each point on each line, should satisfy the other line. That is only possible when both the lines lie on top of each other. Let's try doing that using the value, like changing the values in the sliders. I've added a slider for A and for C. Let's start changing the values. So as I change the value of A, it's coming closer to blue, and there you go. Both are coinciding now. A is equal to 1.5. So we directly get the value of A as A is equal to 1.5. All are coinciding. All the values are, okay, no, this isn't, yeah. So the two lines are meeting each other at all points, and the value of A is 1.5. So A is 3 over 2 or 1.5. This is the correct one. See, you got to solve directly through DESMOS. Otherwise, what's the direct rule? The rule is for infinitely many solutions, the coefficients, the ratio of coefficients must be same for each. So like half, this is the coefficient of x in the first equation, divided by A should be equal to 1 by 3 over 1 should be equal to 1 by 6 over C. So from here also you can solve the equation, okay, for the value of A. If you pick just this two, it's A is equal to 3 over 2, or from DESMOS, as we can see. Okay, going for the next one. A movie theater sells two types of tickets, adult tickets for $12 and child tickets for $8. If the theater sold 30 tickets for a total of $300, how much in dollars was spent on adult tickets? Okay, so adult tickets are costing $12, child tickets are $8, and in total they sold 30 tickets for a total of $300. So our approach is going to be to quickly form two equations. As we can see, there are two variables, adult and child. So let's say adult is y, child is x. Okay, child ticket. So then the first equation would be total number of tickets, x, child tickets, plus y, adult tickets, is equal to 30. That's given to us. And then adult ticket costs $12 a piece. So 12y plus child tickets $8 a piece, 8x is equal to 300. And head immediately to DESMOS to solve these equations. Okay, x plus y is equal to 30. Let's clear this up. X plus y equals 30, and then 12y adult tickets plus 8x child tickets is equal to 300. Where are they meeting? They're meeting at 15, 15. That means equal number of adult tickets and child tickets were sold, x and x. So how much in dollars was spent on adult tickets? So number of tickets, x number of tickets, that was 15, y the adult tickets, that's also 15. Now total amount spent on adult tickets, that means 15 times 12. 12 times 5 is 60, 0 carry 6, 12 times 1 is 12, plus 6, 18. So $180 spent on adult tickets and $120 spent on child tickets. Okay, let's go on to the next one. Okay, so you're given two equations, y is equal to half x plus 8, y is equal to cx plus 10. In the system of equations above, c is a constant. If the system has no solution, what is the value of c? Okay, so if the system is given to have no solution, so basically for any system of equations there are certain conditions. The conditions are written in terms of like this: a1x plus b1y is equal to c1, and a2x plus b2y is equal to c2. So if you remember the conditions, if you're able to remember the conditions, you can solve directly, like manually. So a1 upon a2 not equal to b1 upon b2. Okay, this will give you distinct solutions. Okay, real distinct. Then a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Okay, this will give you infinite solutions. Infinite solutions. Okay. And then next one, a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. No solutions. Okay. This has no solutions. Basically these two are parallel lines. The system represents parallel lines. This one represents overlapping lines. That's why infinite solutions, overlapping lines. And the first one represents intersecting lines. So they just intersect at a single point. Intersecting lines. Okay. Now let's see how do we do this using DESMOS. Okay, I just want to show you. Okay. So y is equal to half x plus 8. We write that y is equal to half x plus 8. Next one, the equation is given y is equal to cx plus 10. Y is equal to cx plus 10. Okay. Let's add a slider. Now we add a slider for c. Right now the two lines are intersecting. Okay. The green one is our reference line. Right now they're intersecting. We need to do something such that they become parallel. So then in that case they'll never meet. Let's start sliding for the value of c. Okay. This side it's going like that. Okay. And now it's parallel. C is equal to 0.5, it's parallel, as you can see. There are no points of intersection. Zoom out, zoom out. You'll see no points of intersection. And you can zoom in further to check if they're parallel or not. Yeah. They are. As you can see, they're maintaining that consistency. They are parallel. Okay. Okay. Now C is equal to 0.5. We can place it here. Okay. So that becomes our answer. And from the rule also we can see that a1 upon a2 should not be equal to c1 upon c2 and should be equal to b1 upon b2. So the coefficients of y are same, coefficients of x would be same, so half and half, and the constant terms would be different. Okay, so this question is not, you should not do it using DESMOS because it'll take more time doing it with DESMOS. It's pretty evident that all coefficients are same and just the constants are different. That means the x coefficient would also be same for no solution. Okay, but if it were to be done using DESMOS, so I was just trying to show you how to find a line parallel to a given line on DESMOS. Okay, that was in short what I was showing. Okay, let's go for the next one. Okay, we have an equation 1 upon x squared plus 10x plus 25 is equal to 4. If x is a solution to the given equation, which of the following is a possible value of x plus 5? Okay, we need to solve this equation, find the value of x, and then finally find the value of x plus 5. As we can see directly, 1 upon x plus 5 squared, that's what this is. X squared plus 5 squared plus 2 times 5 times x is equal to 4. Okay. So we can transfer this to the other side. Just do cross multiplication. 1 by 4 is equal to x plus 5 squared. Okay. 1 by 4 is x plus 5 squared. So x plus 5 can be plus minus 1 over 2. So positive 1 over 2 is given here. If you were to do this through DESMOS, in case you're not exactly able to identify immediately that this was x plus 5 squared, in that case this would become a longer question to solve. So let's do it through DESMOS. 1 upon x squared plus 10x plus 25. 1 upon x squared plus 10x plus 25 is equal to 4. So just to clarify here, if you want to write everything in the denominator, just don't press the right hand side key. Like keep writing. For example, I can show you again. 1 upon, so first I do 1, then press the slash. Okay, so it goes down. Now x raised to the power 2, press the right side right hand key once. Okay, the moment you press it twice, it will come out of the denominator. So just press it once and then write plus 10x plus 25, and then press the side key again. So this here is the graph of this given function. Okay, 1 upon x squared plus 10x plus 25 is equal to 4. Now we need to figure out the solution for this and the value of x plus 5. Okay, so zooming in, let's check where does it cut the axes. Okay, so right now, as you can see, it's not showing you where the function is like going to 0, where the y is going to 0, because the way we've written the equation, 1 upon x squared plus 10x plus 25 is equal to 4. So it has just drawn the graph. The moment you pull the 4 to the other side, so you write minus 4 is equal to 0. Now you can see the points, negative 5.5, 0, negative 4.5, 0. These are the values of x. Okay, so x is equal to negative 5.5, x is equal to negative 4.5. You add a plus 5 to both, you get a 0.5 and a minus 0.5. So 0.5 is the correct one from the options. Okay, so you see, we can use Desmos to solve a variety of difficult questions. In the next video, I'm going to come up with even more harder questions coming on the SAT Math, which you can solve in under 20-30 seconds through your Desmos graphing calculator. Okay, if there are any suggestions or questions, put them in the comments. Don't forget to do that. Okay, like, share, subscribe. Take care. Bye-bye.